Rendezvous is the act of meeting up with another entity in space. But in order to understand rendezvous, some vocab words must be understood first. One of those vocab words is prograde, which is the direction that an object is going. A prograde burn is when you fire your engines while facing prograde. Retrograde is the opposite of prograde. An apoapsis is the highest point in orbit, while a periapsis is the lowest one. A final vocab word is period. The period of an orbit is the amount of time that it takes to complete one orbit. So now let's say you want to send a probe to the center of the sun. How would you do it? The simplest answer is to burn prograde along Earth's retrograde vector. This will make it so that you accelerate relative to the Earth, but once you leave Earth's gravity well, your velocity is in the opposite directions of Earth's, so they are subtracted from each other. This requires a ton of delta v. Another method is to accelerate out along Earth's prograde vector. This makes you go up away from the sun because your velocities are added, not subtracted. Then once you reach your solar apoapsis, you can perform a very small retrograde burn to send you into the sun. This works because as you approach apoapsis, your speed is taken away by gravity, so you need less delta v to perform a periapsis change. The amount of energy required to send you into the sun is equal to your velocity, because if your velocity ever hits zero, then you will start falling straight into the surface of the sun because of gravity. This method requires less delta V, but a lot more time, and most solar probes cannot spend this long in space. You could also use gravity assists to go into the center of the sun. A gravity assist is when you use the gravity of a planet to change your velocity. Planets are spinning, and their gravity is also spinning. It is possible to use the spinning motion of gravity to slingshot a ship. If the craft travels with the spinning motion, then it gains energy, and if it travels against the spinning motion, then it loses energy. Think of it like when you drop a bouncy ball in a frictionless room. The ball will bounce back to the same height. But if the floor that it bounced on was moving, then it would gain either negative or positive energy based on the direction that the floor was moving when the ball impacted. If the ball was a ship and the floor was a planet, then that would be a gravity assist. Now let's say that you are piloting a Dragon capsule on a commercial resupply mission to the ISS. You want to rendezvous with the station that is ahead of you. How do you do it? If you said burn towards it, you were wrong. This will cause your apoapsis height to increase, which will increase the period of your orbit, and you will actually be drifting further away from the station after each orbit. This is a very difficult challenge. The astronauts aboard Gemini 4 failed the rendezvous for this very reason. You would actually want to burn away from the ISS to decrease the period of your orbit so that you can catch up with the station. If you want to rendezvous with something that is behind you, then you would raise your orbit so that it can catch up with you. Now let's say that you want to get from Leo to Mars. How would you get there? Mars is at a higher orbit than Earth, so you would want to leave Earth along its prograde axis so that your velocities are added together. You would also use a method known as a Hohmann transfer. In Hohmann transfer, you first enter an elliptical orbit that will reach Mars's orbit at the same time that Mars hits the intersection between the orbits. In order to do this, you must launch at a specific time of year so that when you leave Earth perfectly along its prograde axis, you will get a close encounter with Mars. Hohmann transfers work on the principle that as you reach your apoapsis, you slow down. This means that at first, it will look like you're going to miss Mars, but as you approach its orbit, you slow down so you hit each other at the same time. Once you are in Mars's SOI, you'll have so much velocity that you'll skip out of it. This is fixed using a retrograde burn at Mars periapsis, so that you slow down enough in order to be in orbit of Mars. Once that is complete, you are captured at Mars. But that retrograde burn costs a lot of delta V. So most craft will use an aerobrake to aid in capturing. An aerobrake is when you use an atmosphere to slow yourself down. While the Martian atmosphere is not very thick, it still produces enough drag to slow a craft down. Hohmann transfers are the main method of rendezvous with a planet